Again, the opposite side is the side across from theta, the adjacent side is the side next to theta, and the hypotenuse never moves. It is the side across from the right angle. Now, when we bring up these trig functions to solve for these missing parts of right angles, we always use the acronym SOHCAHTOA. I still, with all of my years in math, I still say this in my head when I'm setting up trig functions. This acronym tells you exactly how to set up these ratios in the trig function. So if I am talking about sine, which one of these portions of the acronym do you think I'm referring to? So, ca, or to? Yeah, for sure. So, right? SOH. The S stands for sine. So sine has O as the first letter and H as the second, meaning your trig ratio for sine is the opposite side over the hypotenuse side. The first letter over the second letter in that acronym. Knowing that, what do you think the cosine, how can we finish this cosine function? What's the ratio they're going to be? Adjacent over hypotenuse. And lastly, tangent. What is tangent going to be? Yes, opposite, because the tangent is TOA. The T stands for tangent, then the O stands for opposite, and the A stands for adjacent. So good tells you how to write these ratios to finish the functions. Now, the next part is new. And I really hate to introduce it now, but it does need to be introduced at some point, so I might as well introduce it now. You actually do have 3 more trig ratios. Now, it's not anything brand new because these 3 trig ratios are technically termed the reciprocal functions, meaning these 3 trig functions are formed by taking the reciprocals of the originals. So technically, cosecant is the reciprocal of sine, and secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. So I'll even write that here. Recip of sine. Recip of cosine. And recip of tangent. Cotangent is really easy to remember. Okay, yeah, it goes with tangent. The other two kind of get you, or well, I don't know you, but they kind of get me mixed up, and I have the hardest time remembering. Okay, cosecant goes with which one? So how I remember it is because it's the reciprocal, because it's the opposite. The sine that starts with an S goes to the one that starts with a C, and the one that starts with a C, cosine, goes to the one that starts with an S. So secant that starts with an S goes with cosine. Cosecant that starts with a C goes to sine. That's how I remember it. You can come up with another way. So all that this means is cosecant takes sine and flips it. Hypotenuse over opposite. Secant takes cosine and flips it. Hypotenuse over adjacent. And cotangent takes tangent and flips it. Adjacent over opposite. So basically at this point, as long as you have the original functions, it's not really much work. You just have to flip the fraction over. Okay. So let's start trying to find these 6 trig functions. Any questions? Okay. So I'm going to do, now this part seemed to take the longest. Should I skip over the easy one? Let's see. Thumbs up if you want to see an easy one and a hard one, or thumbs down if you just want to see the hard both. Okay, okay. I'll do both. I'm gonna do this first one really quickly though. So we're trying to set up, all this wants is us to set up these trig functions. We're not actually solving for theta here. Just know that with any one of these trig functions, once I set it up, I can then solve for theta. That's the whole point. That's the whole point in setting up these trig functions, is in order for us to solve for theta. Okay. So I'm going to, as always, when I'm dealing with trig, write my SOHCAHTOA because it's going to help me. If you've already got this down, memorized, you don't need to write it, but it is nice to reference. So, first thing I do after writing SOHCAHTOA down is look at my triangle and relate my sides. So, theta being in that upper right angle, where then is my opposite side from theta? It's the side across from theta, the side not touching that angle at all. 12 is our O. Where is our adjacent side? Mm-hmm. Mm-hmm. And then where is, because the adjacent is the one right next to theta, not hypotenuse. Where's the hypotenuse? Oh, you guys jumped the gun. You're like, all right. So having these things labeled makes my life much easier because I now know if I'm looking for sine, according to my acronym SOHCAHTOA, sine goes with so it's O over H, meaning I just need to write 12 over 13. O, my O side, which is 12, over my H side, which is 13. Cosine is ca, A over H, which means I write 5 over 13. Tangent is TOA, OA, so that's O over A, 12 over 5. And then the other three, remember just the reciprocals of the one that they go with. So cosecant goes with sine. You flip the sine ratio and do 13 over 12. Secant goes with cosine. You flip the cosine ratio. And cotangent goes with tangent. You flip the tangent ratio. And you're done. The reason why this one is so easy is because you didn't have to simplify any of the fractions, right? You didn't have to simplify any of the fractions, and you didn't have a square root in the denominator, which is what we're about to do. So over here, first thing I'm going to do, just like last time, is label my sides. OA. So from theta, which side is my opposite side? Yes, 4. 4 is my opposite across from theta. Where's my adjacent? Yes, 8. And what's my hypotenuse? The one across from the right angle. No one wants to look at this one. 4 squared is my hypotenuse. So sine is O over 8, meaning I have to write 4 over 4 square root 5. Now, there are two things wrong here. Yes, you know, there are two things wrong, or not wrong, but need to be fixed before I get my final answer. What is one of the things that I need to do here? Yeah, you need to simplify the fourth cancel, and yes, Ursula, you cannot have a square root in the denominator. Anytime you have a square root in the denominator, it technically turns an irrational number. So you need to do something that's called rationalizing the fraction. We did do this in geometry, and we did do it a bit in algebra 2, I believe. Did we do it? No, we didn't do it in algebra 2. So this is 2 years ago. But yes, we know that these 4's will cancel out. So we're left with just a 1 in the numerator. Now, does anyone recall, how do we get the square root of 5 out of the denominator? Multiply both sides and then so I know you want a square, and that is your go-to for getting rid of square root. However, this is not an equation that I can square both sides and keep equal. This is just a single fraction. This is just a single fraction. If I square it, I'm changing its size. I can't do that. I don't want to change its size. I want to keep it the same size. What can you always multiply by and not change something's size or value? 1. Yes. So what you do here is you multiply both the numerator and the denominator by your radical, square root 5. Because what is the square root of 5 times the square root of 5? I had to ask the last class this too. What is the square root of 3 times the square root of 2? What do you do there to combine this? Oh boy. Not add. It's not a trick question. It's exactly what you think would happen. You just multiply the numbers inside the radical. So the square root of 3 times the square root of 2 is the square root of 6. So what is the square root of 5 times the square root of 5? Yes. And what is the square root of 25? So what happens when you multiply a radical times itself? What is your end result? Always the number inside. So here I multiplied by the square root of 5 over the square root of 5 because when you multiply the square root of 5 times the square root of 5, you end up with 5, effectively getting rid of the radical. So now in the numerator, I have 1 times the square root of 5. My end answer, my end result is the square root of 5 over 5. So now this is a rational number. I got rid of the square root in the denominator. Okay, so let's try it again with cosine. Cosine is ca a over h. That's 8 over 4 square root 5. Right? I'm just looking at this. So ca toa. The ca is what I'm dealing with now. A over h. Now, what do I have to do first here? What's the easy peasy part? Simplify, yeah. So 8 over 4, what goes into both 8 and 4? 4 does. So you are dividing out of 4, and 8 divided by 4 is just 2. 4 divided by 4 is 1, so there's nothing here. But then, to get the square root out of the denominator, you're multiplying by that square root over itself, because that is equivalent to 1. I'm not changing its size, I'm just multiplying by 1. The square root of 5 times the square root of 5 gives me 5. And what do I have in the numerator? Yes. You know, you can, if you guys don't like typing, you can unmute yourself. incredibly hard to type an equivalent to square root. So basically, anytime you have a square root in the denominator, you can think of it as the square root moves to the numerator, and it's just the inside number on the bottom. So if you had 6 over square root of 7, it would be 6 square root 7 over 7. That's how you express. All right. Tangent O over A, TOA is O over A. I'm now dealing with this portion, TOA. So O over A gives me 4 over 8. And this one is simple. I don't have a square root at all. I just have to simplify. 4 over 8 can simplify down to a half. Yes. Now, the reciprocal functions aren't as easy this time as last time, because if I just take this end result I had for sine and flip it, what happens? Oh my gosh, the square root's back in the denominator. I just did all of that work and then I'm putting the square root back up in the denominator? No, not about to do all that work again. So instead, whenever you have something like that, you flip it and you're putting a square root back in the denominator, look at the original. Look at the original ratio you wrote and flip that in. So I have 4 over 4 square root 5. It becomes 4 square root 5 over 4. And the 4's still divide. Whoops, what am I about to write? And you're left with the square root of. Secant, same thing. Look at the original. You can just look at, you simplified the 8 and the 4 down to just 2 in the numerator. So if I'm finding the reciprocal of cosine, what do I end up with? Exactly. And what about cotangent? Just the 2. Yeah, that one you can just flip the end result because there are no square roots in it. Right? Are there any questions? All right. So I am going to do number 8 instead. Now, what this portion of these problems, this work wants us to do is take this one trig function and use it to find the rest of the trig functions. Oh, you wanted me to do this hard. Well, we'll see after this hard one if you still want me to go back and do this one. So, um, again, what this wants me to do is take this trig function and use it to find the rest of the functions. Anytime you're dealing with trig and there isn't a triangle drawn, you need to draw that triangle. So that's what I'm going to do first. I'm going to draw a right triangle. Now, do you think it matters where I put theta, where I put my angle? It doesn't matter. All that matters is that you're consistent on where the opposite, adjacent, and hypotenuse sides are. So I can put it, and don't write, well, I'm going to put it here, but I could also put it down in this bottom angle as well. But you cannot ever put it on the right angle. Your theta is never that right angle. All right, so theta being there, I now need to look at the trig function they gave me, which is secant. Now remember, secant is the reciprocal of which function? Cosine. Yes, it starts with an S. It goes, wow, why did it do it? Starts with an S. Stop it. And so that means it's the reciprocal of the other lettered one, cosine. And we know cosine, if I'm looking at SOHCAHTOA, is A over H. So this is the reciprocal of A over H. It becomes H over A. But look, it's only a 4. That's not a fraction. What do I do? How can I make a whole number a fraction? Yeah, it's always over an invisible 1. So what this means is 4 is my hypotenuse and 1 is my adjacent. So where on this triangle is my hypotenuse? Yes. So it's that diagonal line I have drawn there. That's my hypotenuse. And I'm still going to put the H on it, just so I know that's my hypotenuse. Where's my adjacent? On the triangle. Where's the adjacent side? Right next to the theta. Good. And it tells us in the, whoa, it tells us in the function that the adjacent side is 1. So I put a 1 on that adjacent side. And then my third side that I don't have yet is my opposite side. So when I'm dealing with a trig function that has an O in it, like sine and tangent, I know I'm going to need that opposite side. What am I going to have to do to find that opposite side? Oh my goodness, the Pythagorean theorem is resurfacing. Yes, you have to use the Pythagorean theorem. A squared plus b squared equals c squared. You can always apply Pythagorean theorem to right triangles when you're missing one side length. So here, on this problem, I'm missing a leg. So I'm missing either A or B. It doesn't matter which. Now what I'm going to do is I'm going to show you the shorthand version of the Pythagorean theorem that I do. Yes, you can plug them in here and solve, solve, solve. Or you can just know I'm having to solve for one of the legs, meaning I'm going to get b by itself here. So I'm going to get b by itself. I'm going to subtract a squared to the other side. So it's c squared minus a squared, but then it's b squared. How do I get that b unsquared to turn into just a plain b? How do you get something unsquared in an equation? Square root both sides. So look, anytime you're missing a leg, this is what you're using if you're trying to do the short version. You can continue using Pythagorean theorem, but this is less work because whenever you're missing a leg, you just know it's the hypotenuse squared minus the other leg squared. And you take out your calculator. Ugh, why does it keep doing this? Also, on Schoology, I put these two. There's two. If you want this calculator, you can only get it on your personal device. But if you do have a personal device and want to have this digital calculator, I put the two files you need to download to get it, by the way, on Schoology. Okay, so in my calculator, I just put this whole thing, the square root of the hypotenuse squared minus the leg squared, and you get the other leg. Oh, so because it gave me decimal and it didn't give me a whole number, we always want to leave things in simplest radical form. So it giving me, I never really, in trig, I never really want to write a decimal unless it's the final answer. Instead here, I have to leave it in simplest radical form. I have to actually do 4 squared minus 1 squared. 16 minus 1 is 15. So I have to leave it. This opposite side is actually just the square root of 15. Does anyone know, can the square root of 15 be simplified? Is there a perfect square that is a factor of 15? No. 15 is as simplified as it can go. So I leave it just like this. So now that I have all three sides, I can now find all six trig functions. Sine is opposite over hypotenuse, so it's the square root of 15 over 4. Cosine is adjacent over hypotenuse, 1 over 4. Tangent is opposite over adjacent, so it's the square root of 15 over 1, which just simplifies down to the square root of 15. Now cosecant is the reciprocal of sine. Look what happens though when I find the reciprocal. Oh, who is messaging? Let me mute this. Okay. So what do I need to do here? Can I leave this answer like this? I need to do what I was explaining above, that I need to rationalize the denominator, meaning I multiply by the square root of 15 over the square root of 15, and it gives me 4 square root of 15 over 15. Secant, the reciprocal of 1 over 4 is 4 over 1, which simplifies to 4. Cotangent is 1 over the square root of 15. So again, this is another one I have to rationalize, making it the square root of 15 over 15. Are there any questions on this one? Again, I have all of these answers for these other 3, 5, 6, and 7 keyed. And if you are really struggling, you can go and look at my key and find the problems. All right, we're actually going to skip special right triangles. That's not needed for today. We're going to come back to that. And I am probably going to go over a few minutes, but I do at least want to get one of these done, if not two. And I'll record myself doing these two and this one probably. Okay, so I at least want to get these two done because this is actually applying trig to problems. This is using trig to find missing parts of right triangles. Before now in these notes, it was just setting up the trig ratios and functions. We have to learn how to set them up in order to then know how to solve. So now we're actually going to apply. First thing I always do, I always like to, jot down my acronym. If you have this memorized, do you really need to write it down every time? No. But it's good to reference. After you write down your SOHCAHTOA, then my next step, when I'm trying to find missing parts on a right triangle that I'm given an angle, and I'm trying to find other side lengths, my next step is to label. I have to label my triangle with theta, which is the angle I'm dealing with, my opposite side, which in this case is 11, my adjacent side, which doesn't have a value on it. I'm not going to be using that A really. And then my hypotenuse. So here, the only sides I'm dealing with are O and H. Because I'm only dealing with O and H, that makes this a sine function problem. Sine of theta is O over H. Now theta in this case is 32. O is 11, and H is X. How do we go about getting X by itself? Yes, multiply by the denominator, which in this case is X. The X's cancel, and so you're left with X sine 32 equals 11. But then is the X by itself? Put it in the calculator. Can't quite yet. How do we get the sine 32 off of the X? Right now, all of that 32 is tied to the sign. It's not just the number 32, it's the sign of 32, which is a drastically different number. You can think of this as one term. Whoa. Think of this as one term. You can't separate those. But right now, what's happening? Yes, you have to divide by sine of 32. Divide both sides by sine of 32, and that will get it off of the X. So you end up with, these cancel, X is equal to 11 over sine 32. Now, if I was doing this on my own, I wouldn't write this. I wouldn't write all this. What I would write is sine 32 equals 11 over X. And then I remember that all of these in between steps are just going to get me to switching the X and the sine of 32 and end up with this. If I was doing this myself, this is what I would do. Anytime X is in the denominator, you can just remember I'm switching X and my trig function and then divide. I used to call it switch and divide. Missing denominator, switch and divide. Does anyone remember what you do if you're missing the numerator? I'll just tell you. You multiply. We'll get to that. So now you have to figure out your calculator, and most importantly, you have to make sure that your calculator is in degree mode, which your calculator will always revert to radians. So your automatic setting is going to be radians. We need to put it in degrees. So you press mode, go down to radian, over to degree, and press enter. If you don't do this, you will always get the wrong answer. Always. It has to be in degrees. So now it's just easy. 11 divided, whoa, not 1, 11 divided by sine 32. And you get 20.76. So because this is the end answer and I've input sine, this is when you can have a decimal. So 20.76. And I'm done. All right. At this point, were there any questions? I really hate to keep you longer. So what I'm going to do is I'm going to say you can leave. If you don't have any questions, you can leave. I am going to continue recording here, and I'm going to record myself doing this next problem, and I'm also going to record myself doing 7, 8, and then 13. All of which, these type of problems, all of which are going to be on your homework. So either you can leave or you can stay. It doesn't matter. All right, so now we're going to do number two. It's the exact same process as before. You first start by labeling your triangle. So I'm going to label my theta as the angle they gave me. My opposite side is the side across from theta, and the adjacent side is the side right next to theta. H is blank. We're not using H. So we just have O, meaning if I'm thinking about SOHCAHTOA, I'm dealing with a tangent problem. Tan of theta is O over A, which my theta here is 75. My O is X, and my A is 21. So now, like I was saying, there are two ways to think about this. Either you can cross multiply and solve. So what I would do here is to get rid of this fraction, you multiply both sides by 21. Or you can remember that whenever you're missing the numerator, you're just going to multiply the trig function times that denominator. So in our calculator, we do. Now, also I wanted to state, I always put the whole number that I'm multiplying by in front of my trig function. I do this because if I do my trig function, I have to remember to close my parentheses, then multiply by the whole number. Whereas if I had put 21 in front, I do not ever have to remember to close the parentheses, which I'm lazy. I don't want to have to remember to do that. So I put the whole number first. See, watch what happens when you don't close the parentheses. You get something really off because it's actually taking the tangent of both of those numbers because you never close the parentheses. So here our answer is 78.37. And you're done. Any questions on these types of problems where you're actually solving the same part? Okay. So I do at least want to do uh, one of these missing angle problems, and then I'm going to tell you all that you can leave because I am going to continue recording, but you can understand, if you watch me do 7, you can understand how to do 8, and then also you can fully solve for 15 as well. The only new information is up to number 10. So after 7, I'm going to kick you out. All right. So here, even though we're missing the angle, it's still the exact same process. We first start by labeling our triangle. Theta is already labeled. That's our x. That's what we're missing. That's what we're trying to find. Our opposite side is the one that's blank. We're not using it. Our adjacent side is 18, and our hypotenuse is 23. So here I'm dealing with A and H, meaning that this is a cosine problem. So I fill in my values. I don't know what theta is. That's what I'm solving for. My A is 18 and my H is 23. What can you do here to get the cosine, to remove the cosine from the theta? It's not a trick question. Instead here, if I had my variable times 2, what would you do to get the 2 off of the x? Yes, so in this cosine problem, what do you do to get the cosine off of theta? Yes. However, have you ever really seen a trig function like dividing by a trig function? No. Instead, what they do, what's another way, if I had this, what's another way to write 1 over x to get the x out of the denominator? It has something to do with the putting something different as the x. Do you guys not know? Okay, I'll just tell you. Anytime you want to get, yes, yes, you raise it to the negative one power. That's how you can write something out of the denominator, but still it's like the notation for it was in the denominator. So here I'm dividing by cosine, but I don't really want to put divide by cosine. Instead, I can multiply by the inverse of cosine or take the inverse cosine. This is the same thing as saying divide by cosine. So if I'm dividing cosine by cosine, they cancel. So theta is just cosine negative 1 of 18 over 23. And that's what I put in my calculator. To get inverse cosine, you just press second cosine. The only time you're pressing second and then it's your function is when you're trying to find an angle. So here you do 18 divided by 23, and you get 38.49, which rounds up to 38.50. So theta is 38.50 degrees. Are there any questions? Okay. That's all I want to hold you for. Again, if you're confused on any of this, I am going to keep recording just to do a few more examples. And also, I will post my key that has all of these problems filled out in case you need more examples. But also, Math Excel, anytime you're working on a problem in Math Excel and you don't understand how to do a problem, don't click help me solve this problem. Click help me or show me a different problem or a similar problem. Then it will step you through a similar problem without like taking away your credit for that current problem. That is really helpful to use that application on Math Excel. All right, so that's it for today.